Hello students, welcome to online maths classroom. This is part 5 of your topic integration, and in this part we will discuss integrals using method of partial fractions and solutions of NCERT exercise 7.5. So let us start with it. Integration by partial fractions. Recall that a rational function is defined as the ratio of two polynomial functions in the form of qx, where px and qx are polynomials in x and qx not equal to 0. Okay, so if degree of px is less than the degree of qx, right, then we know that the rational function is called as proper. Otherwise it is called as improper. The improper rational function can be reduced to proper function by division method. Okay, long division method, that means I can divide px by qx, so that I can represent this px by qx as quotient plus remainder upon denominator. Okay, it is the process of expressing this rational function as quotient plus remainder upon denominator, okay, or divisor. As we know how to integrate the polynomials, the integration of any rational function is reduced to integration of proper rational function. And the rational function which we shall consider here for integration process will be those whose denominators can be factorized into linear and quadratic factors. Okay. Now, as we know that if some means integral is of the form of linear upon quadratic, right, that can be factorized by using the concept that we used in exercise 7.4. Okay, like putting like linear as a times d dx of denominator plus b, right, and getting the values of a and b, you will be able to break up the linear, and the question can be split into two integrals of the form of f dash x upon fx plus 1 upon quadratic, and can be integrated easily. But if in such case of linear upon quadratic, if the denominator can be factorized, properly factorized in the form of linear or quadratic, means if the denominator is cubic one, right, in that case you will get one linear or one quadratic factor, or all the three linear factors. In that case you can means integrate this integral by px by qx as a proper rational function, right, and we will use a method that is called as method of partial fraction decomposition. So you have to follow a chart how to decompose the functions. Okay, so let us see. Now, if the form of rational function is like linear upon quadratic, but the quadratic can be factorized as non-repeated factors x minus a into x minus b, then the partial fraction will be of the form of a upon x minus a plus b upon x minus b. If it is like px plus q upon x minus a whole square, so it will be like a upon the first with degree 1 and the second with degree 2. So a upon x minus a plus b upon x minus a whole square. And like as 1, if the means in the numerator it is quadratic and below it is cubic and factorized in case of like your non-repeated factors, so the partial fraction will be a plus b upon x minus b plus c upon x minus c. Like in case of this like as in number 2, if it is like px square plus qx plus r and you have a repeated factor x minus c whole square and x minus b, so you can write it as a upon this x minus c, like here we did with power 1, then plus b upon x minus c whole square, and the last factor plus c upon x minus 1, right? Okay, and the number 5th is px square plus qx plus r upon x minus a into x square plus bx plus c. Okay, so it is quadratic upon, this is your linear factor, this is quadratic. Now here you should be very careful, and I should split it like I'll take the linear factor as a upon x minus a plus. Now as you know, the degree all means it is a linear, so the means you have taken a constant in the numerator, right? So means if it is quadratic, I have to take some linear in the this numerator. So it will be like bx plus c. Okay, it will be like bx plus c. I'll take in the numerator, and getting the values of a, b, c, I'll be able to break this as two integrals, and integration can be then done. So let us start with exercise 7.5, and number 1 is x upon x plus 1 into x plus 2. So again it is of the first form, so I'll take this function, right, break it to partial fraction a upon x plus 1 plus b upon x plus 2. Okay, take LCM both sides, you will get it as, say, means after LCM this denominator will get cancelled, and I'll get just the numerator as x equal to a times c x plus 2 plus b times x plus 1. Now separate the terms of your coefficients of x like a plus b times x plus 2a plus b, right? So now equate, comparing the coefficients of x on both sides, you'll get a plus b as 1 and 2a plus b as 0. Okay, now we need to solve both of them, right? We will solve like you can do is equation number 3 minus 2, b will get reduced and I'll get a as -1, and by putting this value here I'll get b as 2, right? So means I have learned how to split it. It will be split like -1 upon c, a is -1 upon x plus 1 plus 2 upon x plus 2, and then I can apply the sign of integration to both sides, and I can separate these integrals like -1 upon x plus 1 dx plus 2 upon x plus 2 dx, right? So it is your -1 upon linear is minus log mod x plus 1 plus 2 log mod x plus 2 plus c. Okay, now here I need to apply the property n log m is c, log m raised to power n. Okay, minus log x plus 1 plus c, so log a minus log b can be written as log a plus upon b plus c, right? So this is how we. Now number 2 is no doubt mentioned in the exercise of partial fraction, but instead of factorizing it like x minus 3 into x plus 3 and then making partial fraction, if it is not asked to do it by partial fraction, it is better suggested to reduce it to like your some particular type of formula like we did in 7.4. 1 upon x square minus 9 can be written as x square minus 3 square and can be easily integrated by using the formula 1 upon x square minus a square, that is 1 upon 2a log mod x minus a upon x plus a plus c, instead of using partial fractions. So number 3 is again like your question number 1. So I'll make it partial fraction as a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. Now take the LCM, you'll get 3x minus 1 as denominators are cancelled. So it is, you can see a times x minus 2 into x minus 3 plus b times x minus 1 into x minus 3 plus c times x minus 1 into x minus 2. Okay, now separate all the terms and means equate the coefficients of x square. So x square you can see here is a plus b, means it's suggested that altogether you write together, right? A plus b plus c. So here it is not, there is no coefficient of x square, so a plus b plus c is 0. Similarly, you will get for x to 4, 5a plus 4b plus 3c as -3, and for constant 6a plus 3b plus 2c is -1. Now you can solve all these 3 exercises. Firstly, you can multiply this 2 by say 5 and subtract it from 3 to get a reduced equation in terms of b and c. Then multiply it by 6 and subtract it from your number 4 to get equation in b and c. And those 2 equations obtained can be solved by a method of linear equations to get the values of a, b, c. Okay, in whatever order you can, we will get the value of a as 1, b as -5 and c as 4. So my integral that breaks to this form, okay, and we can integrate it as 1 upon x minus 1 minus 5 times 1 upon x minus 2 plus 4 times 1 upon x minus 3, and all will be in log mod form. Similarly, number 4 can be integrated like this: a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. This is how we represent after taking LCM and separate all the terms of x square, x and constants. First equation a plus b plus c 0, 5a plus 4b plus 3c as -1, 6a plus 3b plus 2c 0. To get solve all of them to get a as half, okay, b as -2, and similarly we get the value of c as 3 by 2. Okay, so this integral can be split it into 3 integrals. Take the constants outside, so it is half log mod x minus 1, for this -2 log mod x minus 2 plus 3 by 2 log mod x minus 3 plus c. Now this number 5 is 2x upon x square plus 3x plus 2. So you can integrate it like also linear upon quadratic also, but you can see that denominator can be easily factorized like x plus 1 into x plus 2. So we can split it to partial fraction a upon x plus 1 plus b upon x plus 2, means multiply, take LCM, separate a and b terms. First equation a plus b 2, 2a plus b 0. A you will get solving a -2b as 4. So this can be split like, okay, your -2 upon x plus 1 and plus 4 upon x plus 2. So which can be integrated easily as -2 log mod x plus 1 plus 4 log mod x plus 2 plus c. Okay, so this is the required answer. You can even raise to powers and apply log a upon b. That reduction can also be carried. Okay, now number 6. Now number 6 is a quite different one, right? What it says, it is quadratic upon quadratic, right? Degrees are same. It is not a proper rational function. So here I have to reduce this to proper rational function as degree of numerator equal to degree of denominator. So we must divide the numerator by denominator to make the degree of numerator smaller than the degree of denominator, so that we can form partial fractions. So for it, what will I do? I divide numerator by denominator, okay, and I'll divide it till I get the remainder, degree of remainder less than the degree of divisor, okay, and then express this function as quotient plus remainder upon denominator, that is half plus this is remainder and this is denominator, okay. So this function can be expressed as this. So first portion can be half of 1 dx plus the second one is your this. So it is again now linear upon quadratic, for which I'll frame fractions. So this is taken outside, a upon x plus 1 upon b upon 1 minus 2x, means take LCM, equate to get your a as 1, b as 3 by 2, and then I can split it this integral. You can, this is log mod plus 3 by 2, it is log mod 1 minus 2x, and be careful, I have to divide by the ddx of 1 minus 2x, that is minus 2 plus c, okay. So don't forget that actually the question was involving, you have to come back to equation number 1 where 1 by 2x was there, okay, because we discussed this integral separately, but it was alongside associated with half of x. So all the values taken from that equation will give you this. Number 7 is integrate x upon x square plus 1 upon x minus 1. Now you can see that the denominator is having a quadratic, irreducible quadratic polynomial and a linear one. So I'll make the partial fraction as ax plus b upon x square plus 1 plus c upon x minus 1, or I can take the linear first, like a upon x minus 1 plus bx plus c upon x square plus 1, in whatever way you carry out, but at the top of quadratic polynomial you have to take a linear one, and at the top of linear you have to take a constant one. Again take LCM, okay, separate the terms for x square, x and constant, you will get the equation a plus c 0 minus a plus b as 1, as here your x square coefficient is 0, x coefficient is 1, and the constant term is also 0, so the third one is minus b plus c is 0, and all together they are solved, you get c as half, b as half, and a as minus half. So you'll put back the values here, so it will be like ax plus b it was, so minus half x plus half upon x square plus 1 plus half upon c upon x minus 1. Now separate, I have to bifurcate this integral, so break it, minus half x upon x square plus 1 plus half upon this, means separate this, okay, break this upon this and this upon this, like this, okay. Now I'll integrate, so it becomes your, it means I can divide multiply by 2, or I can go by that process where I can put this x square plus 1 as t, so that's 2x dx is dt, and that will give me dt by 4. In that way also 4 will come here, right? And then I'll integrate it, it will be your say this term will be your minus 1 by 4 log mod x square plus 1, this is your by that formula 1 upon x square plus c square, that is half tan inverse x, and this is again 1 upon linear half log mod x minus 1 plus c. So you can get the desired answer. Again this is a question of repeated one, so how will I reduce to partial fraction? A upon x minus 1 plus b upon the next power x minus 1 whole square plus c upon x plus 2. If it is say x minus 1 whole cube like thing, so it will be like a upon x minus 1 plus b upon x minus 1 whole square plus c upon x minus 1 whole cube, that thing, okay. Now take the LCM, you will take the LCM, separate to get the equations a plus c 0, a plus b minus 2c 1 minus 2a plus 2b plus c is 0, okay. So b is your minus 3c by 2, I'll get from here, c is minus 2 by 9, a is 2 by 9, right, and ultimately I can get the value of also, right. So b is my 1 by 3, right. So this integral can be split into these three integral, which I think everyone is making log mod, okay. Like don't forget x minus 1 whole square will be raised to power x minus 1 raised to power minus 2, and power rule I will use here. It is not, it cannot be done upon, this is not 1 upon linear actually, right, and minus 2 by 9 times, this is again log mod, and this is how 2 by 9, this is say minus, means 2 by 9 can be taken common out of this term and this term, and this is log a minus b log a upon b, like, and this term is separate like minus 1 by 3 x minus 1 plus c. In number 9 means you have to factorize the denominator. So denominator will be like x minus 1 whole square upon x plus 1, you can see. So again the partial fraction are a upon x minus 1 plus b upon x minus 1 whole square plus c upon x plus 1. Okay, so reduce it means take LCM. You'll get the first equation a plus c 0, b minus 3c 3. Third one is this, to get the values of c as half, a minus half, b as 4. Now put all the values in this integral. It can be minus half, okay, minus half log mod x minus 1. And remember, see that now this will be carried like 4x raised to x minus 1 raised to power minus 2, and with power rule it will be integrated, right? So don't forget to proceed for this. So it is like minus log this is means again this is half log mod x plus 1. So from this term and means this term and this term you can take half common, and then it will be you take this x plus 1 first. So log a minus log b can be put in the form of half log a upon b, and it is minus 4 upon x plus 1 plus. Now see here, it is not a irreducible quadratic. It can be factorized like x minus 1 into x plus 1. So we will follow that a upon linear plus b upon linear plus c upon linear. Okay, take LCM. Now you be careful, okay, that ax plus b type we need to just use, but the quadratic cannot be factorized. Okay, so first equation you'll get as 2a plus 2b plus c is 0, 5a plus b is 2, 3a minus 3b minus c is minus 3, and you'll get the values of b as 5 by 2, a as minus 1 by 10, and c as minus 24 by 5. All together can be substituted there. Now you find all of them will be integrated log mod. So it is minus 1 by 10, say log mod x minus 1, 5 by 2 log mod x plus 1, and minus 24 by 5 log mod 2x plus 3. Don't forget to divide, because here the derivative was just 1. So don't forget to divide by the derivative 2x plus 3, that is 2. Okay, and this is the required answer. In number 11 again, you know, this is not also irreducible. So I can factorize like x plus 2 into x minus 2. So again 3, it can be reduced to 3 terms like a upon x plus 1 plus b upon x plus 2 plus c upon x plus 2. Okay, now take LCM, separate coefficients terms, equate a plus b plus c 0 minus b plus 3c 5 minus 4a minus 2b plus 2c 0. I'll get the values of c as 5 by 6, okay, b as minus 5 by 2, and a as 5 by 3. Integral can be splitted like this, and see all of them are linears. So it is 5 by 3 times log mod x plus 1 minus 5 by 2 times log mod x plus 2 plus 5 by 6 times log mod x minus 2 plus c. In number 12, it is clear that the degree of numerator is higher than the degree of denominator. So divide numerator by denominator to represent this as c, quotient x plus a remainder upon denominator. Right? Now equation will be like here. This I have to make the partial fraction of the second term. So the partial fraction will be like x plus 1 into x minus 1, a upon x plus 1, b upon x minus 1. Make it linear. A plus b is 2 minus a plus b is 1, b 3 by 2, a half. And this is the partial fraction, how it is reduced. Now the integration, I'll put back in equation number 1 so that I don't forget this x also. It is yet not integrated. So integral x is x square by 2 plus half log mod x plus 1 plus 3 by 2 log mod x minus 1 plus. Number 13 is again 2 upon 1 minus x upon 1 plus x square. So again it is 1 upon 1 minus a upon 1 minus x, and the second one is your irreducible quadratic, so it is bx plus c upon 1 plus x square. Like so, after taking LCM and equating a minus b 0, b minus c 0, a plus c 2, so I'll get my a and b and c all as 1. Okay, so I'll put back here the values here. So it will be like a upon this plus bx plus c. So bx plus c means all are 1, so it is x plus 1 upon 1 plus x square. So I think it is easily understood and visible that I can separate x upon 1 plus x square and 1 upon 1 plus x square, right? And here it will be means either you can, if you look forward for this, that the derivative of 1 plus x square, that is x is present there. So either you put it as t and then take 2x dx as dt, so that x dx is dt by 2, or you can multiply and divide by 2 already to get this as term, right? So this can be integrated as log mod 1 minus x. Okay, now don't forget, here you have to divide by the ddx, because ddx of 1 minus x is minus 1, not like x. If it would have been x plus x minus 1, then ddx will be 1. Okay, so don't forget, here you have to divide by this also, and this is your half of, because it is of the form of f dash x upon fx. So it is half log mod 1 plus x square, and this is a formula 1 upon x square plus e square, that is tan inverse 1 upon a tan inverse x upon e plus c, right? So this is how we can reduce it. Okay. Number 14, the partial fraction will be like your e upon x plus 2, okay, plus b upon x plus 2 whole square, and in that way we can calculate. Now let us see some other method also here, that this is the way you can do, because we have done already discussed earlier questions also. So here what you can do is, it is a polynomial function of upon linear raised to power k. So I'll put linear as t, x plus 2 as t, x as t minus 2, so dx is dt. So this question can be changed to 3 times t minus 2 minus 1 upon t square, right? So it is 3t minus 7 upon t square, break numerator. So I can get 3 times 1 upon t dt minus 7 t raised to power minus 2 dt, and this can be integrated like this. Okay, so this question can be carried out by this way also if you don't want to proceed by partial fraction. Okay, but if it is asked by partial fraction, you have to follow only partial fractions. 15th, number 15 is says 1 upon x4 minus 1. Like so, this can be factorized as x square minus 1 into x square plus 1, right? So further it can be factorized as x plus 1 into x minus 1. But in that way, what you see is you will get means like a upon x minus 1 plus b upon x plus 1 plus cx plus d upon x square plus 1. So it will be a larger question. So what we did, we put x square as y, right? Okay, and everything is outside the integral. Now I will make the partial fraction like a upon y minus 1 plus b upon y plus 1. Take LCM. A plus b is 0, a minus b is 1, a half, b minus half. Okay, come back here. Now don't nowhere we have put the sign of integration, because why? If you put x square as y, you have to do all that thing 2x dx is dy, right? So we don't want to follow that, because I just want to break the partial fractions. So I'll get the partial fraction of it is like this, and then what I will do is just I will integrate it like this, right? Because the question is in it is your half like upon y minus 1. What I did is I resubstituted y as x square. Okay, I just took out my work and then replaced it. Now I can integrate. Okay, so this is your formula 1 upon x square minus a square, that is 1 upon 2a log mod x minus a upon x plus a, and this is 1 upon x square plus a square, which is your 1 upon a tan inverse x upon e plus c, right? So in this way the question can be done, and this is the second we discussed, that you can even proceed by this method, but I think that this solution is much better as it will be involving larger calculation. Now number 16 is a very particular form, 1 upon x times xn plus 1. Okay, and you will see 20th question that is like this. Okay, in these questions what we do is that actually we have to put this xn as t, or this complete you can put xn plus 1 as t, or single x raised to power n as t. Okay, so you have to search for the derivative. Okay, what is the derivative of x raised to power n? That is nxn minus 1. So firstly I'll make the adjustments, and what I will do in such questions, I'll multiply both numerator and denominator by nxn minus 1. Okay, what will it help me? It will help me in breaking this integral as 1 upon nc. It becomes as x raised to power n, and inside it is xn plus 1. So either you can put x raised to power n plus 1 as t, or you can put x raised to power n as t, whatever way. So it becomes nxn minus 1 dx as dt. So the question changes to 1 by n times 1 upon t into t plus 1 dt. Right? Now this question can be carried out either by partial fractions, means break it as a upon t plus b upon t plus 1, or what you can do is, means as it is a simple question, so in this you can add and subtract t in the numerator. Now break these terms. Okay, t plus 1 upon this and minus t upon this, right? And this simply becomes, as it gets cancelled, it is 1 upon t dt, and it is again minus 1 upon t plus 1. So it becomes 1. This is log mod t, 1 upon n times log mod t minus log mod t plus 1, and log a minus b will give you this result. Okay, now put the value of t as x raised to power n, and you will get this answer. Okay, so if you put xn plus 1 as t, that way also you will get the same thing, right? And same answer will be there, right? So you can proceed by this method also, but here we can, I think it was a simple question, so in it we can add and subtract t, and that way also question can be. Number 17 is a question involving your trigonometric functions, but here also Firstly, I'll look at the question and put sin x as t, so that cos x dx is dt, and question changes to dt by 1 minus t into 2 minus t, right? So again, either you can go for, because you know how to reduce to partial fraction, so I'm not discussing that. It is a upon 1 minus t plus b upon 2 minus t. Other method is, again, you can just means split the numerator as 2 minus t minus 1 minus t. Okay, so see, it will be 1 itself, so 2 minus t. Okay, that this property is used, the difference of two factors in the denominator, namely this is 2 minus t minus this, which is 1. Okay, so means this is also an a way that has been discussed with you, so that you can proceed for the questions like this also, right? So if it is not okay, you can go for partial fraction also, right? So in that way also, question reduces to 1 upon 1 minus t and minus 1 upon 2 minus t. So this integral is log mod 1 minus t. Don't forget to divide by dt of 1 minus t, that is minus 1. And here also same thing, right? So it is minus log mod 1 minus t plus 2, and this log mod 2 minus t plus c. So it is log a minus b, means adjust this first, this second. So it becomes log a upon b plus c. Replace the value of d as sin x and you'll get this answer. Number 18 is very important one. Here again the same thing is there, it is biquadratic upon biquadratic, right? So you should not go for division directly here. Firstly, what I will do is I'll put x square as y, and see, I'm not using any integral sign, because if I'm using integral sign, x square equal to y, I have to change 2x dx as in terms of dy. Okay, I don't want to go for that. I just want to get my partial means reduced terms so that I can integrate, right? So this is just means outside the integral what we are doing. So I'll put x square as y, it changes to quadratic upon quadratic. Again the degree of numerator is same as denominator. I'll divide my numerator by denominator and I'll get this as your quotient plus remainder upon denominator. Still don't use integral sign. Now I will reduce it to partial fraction, like a upon y plus 3 plus b upon y plus 4. Okay, so first equation I'll get by taking LCM is a plus b minus 4, 4a plus 3b minus 10. Okay, b as minus 6, a as 2. Okay, now this integral can be splitted like this, right? Now from here I'll go back to my this previous equation where I started with the first term also. So I'll get three integrals, as this was quotient plus this was 2. This portion is now reduced to partial fraction by 2 upon y plus 3, 6 upon minus 6 upon y plus 4. Now before integrating, I'll replace y by x square, right? So it changes to this. So my work is done. Now I will put the integration sign and now I can integrate it. So see, one can be integrated as x, this can be written as x square plus root 3 whole square, and it is 2 square. Okay, so it is, the formula is 1 upon e tan inverse x upon a. Here also same formula and you'll get this answer. In number 19, what I need to do is, here the same things are quite different as your 18th. Here if I'll put x square as t, I'll get 2x dx as dt, and question changes to dt upon t plus 1 into t plus 3, because the derivative is present in the numerator. Previously in 18th question it was not like this, right? So again now I can just go for means partial fraction, like a upon t plus 1 plus b upon t plus 3. That way means the difference of the two factors you are obtaining as 2. So I'll express this as t plus 3 minus t plus 1. Separate it, you'll get 1 upon t plus 1 minus 1 upon t plus 3. It is half log mod t plus 1 minus log mod t plus 3. It is half log mod a upon b. Okay, put the value of t as x square and you'll get this answer. Now this is number 20, as we did in question number 16, right? You can see it's that form. There it was plus. In that case minus can be there. Here it can be plus like this. Okay, but the form is almost same. So what will I do? I'll check for the derivative of x4. What is it? 4x cube. So I'll multiply and divide by 4x cube. So it changes to 4x cube upon denominator becomes your 4x4, x4 minus 1. Okay, your 4 is outside, right? So I'll put my x4. I told you put x4 minus 1 as t or x4 as t. You'll get the result same. So it is 4x cube dx is dt. Changes, question changes to 1 by 4 dt upon t into t minus 1. So either you can factorize it, or you can go by partial fraction. That way also the question can be done. Okay, so I just use it as t minus that the difference of factors, that property, t minus 1. So break it as integral. This changes to 1 upon t minus 1. This changes to 1 upon t log mod t minus 1 minus log mod t, and 1 upon 4 log a upon b. Okay, put t as x raised to power 4, and this is the required answer. Okay, now alternatively there one more way is there to solve the question. It is like 1 upon x square minus 1 x square plus 1. Okay, break it as factors x minus 1 into x plus 1. So you have to reduce it to this larger partial fraction, but I think this is not worth it, right? You are not supposed to do, because this method will be a very long calculation method, so avoid it. And the question which is done by this method, either break from here to partial fraction, or if you know how to express the numerator as the difference of the two factors, that way also you can proceed. Number 21 is a very good question, 1 upon ex minus 1. Now see, put ex as t. Now this is a question which is very important, and ex dx will be dt, and you will get this will change to like, this is dx is your dt by ex. Okay, so this becomes your 1 upon t minus 1, ex is t, dt by ex. Okay, so it becomes again, this becomes 1 upon t into t minus 1, which you are doing. I think you can reduce by partial fraction, or you did it in 20th question also, t minus 1, break, separate, integrate, put back the value of t as e raised to power x, and you will get the answer. Number 22 is again your two irreducible factors which can be partially factorized like this. Solve it. A plus b is 1, minus 2a minus b is 0, a is minus 1, b 2. Partial fraction is reduced like this, so it is minus log mod x minus 1, okay, plus 2 log mod x minus 2, and the x minus 2 power can be raised to square, right? I think that option number B is going to be the answer. So this way the question can be carried. Dx upon x into x square plus 1. Now you see, again see, this is that form, right? So you can go for that also, a upon x plus b x plus c upon x square plus 1. But if you remember that 16th question, number 16, number 20, that form, so divide and multiply by 2x, right? So in that way, then put x square as t, okay, 2x dx as dt. Question changes to this form. So this is a very popular form, separate, break. You can make partial fraction also, but you can go directly also, put t x square, and this becomes log mod x minus half log x square plus 1 plus c, and option number A is correct. See how the questions can be executed in various ways. So you must be familiar with which way we should use, so that there is less calculation and proper execution of the question. Okay, so this was all regarding method of partial fraction. Please practice it well. Observe the questions, which method is suitable for which question. If you are able to decide, I think there will be no problem, unless until it is asked that you should go by partial fraction, right? You can go for that linear upon quadratic or some other way also, in which the question can be simply integrated, right? But generally it is not asked like this, that integrate using partial fractions. But if it is asked by partial fraction, you have to do by partial fraction. Otherwise, in general, the questions are just like evaluate or integrate, and in that, whatever way, convenient way, you can use. But you must remember that partial fractions are used when there is a proper rational function. Okay, means the degree of numerator is less than the degree of denominator. Moreover, denominator should be factorized, means properly, it should have proper factors. Either both means your factors should be linear, or one linear, one quadratic. That way also you can execute the question. Okay, and if the degree of means numerator denominator is same, you should go for the long division process. In that way also, when you express that term in quotient plus remainder upon denominator, then the second one can be reduced to your proper fraction. Okay, and you can apply partial fraction thereafter. Hope whatever is discussed is clear to you. Thank you so much.